So I've just been working on getting this to render online. I think I made some decent progress here. Oh, the startup time is sort of annoying. That's not that great. But I haven't been spending any time on styling, just have the code here. And if I run this, it is actually trying to render it. Which that's not working, obviously. Right now. It's loading in, setting a few options. The render to OpenGL, removing caching. Importing these. And where's the place where this is actually run? No, it's just here. Here it's taking the scene, here it's trying to render with that scene. Great. So right now, frame buffer object.clear, obviously that would fail. And probably somewhere around update frame, I'm probably gonna want to change some stuff up for the web anyway. OpenGL render 397. So here's where it got render. Then it was trying to update frame. And it got there from 978. Now there's some thinking to do to decide if this is even what I want it to do. Like, do I want this to have the same OpenGL renderer? So this renderer render. Then it came here. And so it's the scene and the objects. And there isn't a ton here that even... Well, I guess update frame is useful. Although... I have to do that without updating this frame buffer object. Frame buffer object.clear. And then refresh perspective uniforms. Which I also don't think I need, actually. I think these are only used for grant shaders. Light source position, focal distance, these things. For now, we have sys imported. I'm just going to not do this. Although there is a way to do this, there's a 3JS equivalent of this, where I can clear the scene with a color. I think. It's probably part of the renderer. Hey, Aquabeam, what's going on? Whether render should clear the color buffer. I think that's not what I'm looking for. And this would be a dot clear, and this takes a color. More web stuff in housekeeping. Definitely more web stuff. It might not be housekeeping anymore. Well, no, that's not true. There's a fair amount of housekeeping I should probably do. Yeah. But I'm not sure how much of it I want to do right now. Oh, but one thing I did want to ask you is that since it's getting close to the release, getting this reviewed would be a big help. I guess I could write up some code to test model matrices if that helps with that. Try the model matrix thing. Okay. Yeah, I could write out some code for that if that helps. Only commented on what you know? Yeah, that's fine. Okay, I'm gonna recompile this. There is a fair bit of shader magic. That is true. Okay. Here. Here it's saying it has no context. I wonder, does this still run? Miraculously, although I don't know what all this printing is. Vectorized object rendering? Okay. Okay, so then this still does work locally, thank goodness. Let me look at this. Okay. So why would it say there's no context here? It must be something specific to the web version. Oh, maybe it doesn't work if you don't have a window. No, I didn't mean to do that. If I don't preview this? No, that still does it. Or maybe it's doing that because this one has an interactive embed. So I do whatever conversion test. Nope, that works too. Okay. This must be something specific to WebAssembly. Has no attribute context, and that's true, actually. Okay, this whole block is only if it isn't WebAssembly, and this is where the context gets created. So OpenGL render 308. Here, where the shader is being created, I won't have this context. So I need to ask myself is, why is that context needed? It's here, it looks like it's mostly just saved. And it's used when it compiles the WebAssembly program. I don't know how much of this class I actually need. Because I don't need that program for WebAssembly. I might not need this at all. If I don't worry about textures right now, the uniforms I can do when in WebGL. Then when it's time to create the mesh, I'll need that vertex data and the indices. Depth test will probably always be true, but I don't need that shader, I don't think. So I'm just gonna take this out. So what'll happen next? I think this should run. This should be, oh, shader.shader program. Maybe this entire render mobject. Maybe this should be another function. Just like render OpenGL mob or WebGL mobject or something. I'm actually gonna try that. So put this back. And what did I just do? Okay, put that back. It's kind of an awkward place for the import modern GL, but I guess I have to keep it there for now. Then here, where it's rendering object, this will be render WebGL object. So I have to write that. Here. And for now, I'm just going to say print render the object here. Okay, recompile that. Hopefully. Okay. Now attribute right frame and FileWriter.write. That makes sense. So I think I need to do. Let's see. Wait, did it print that? It did print render the object here. What's this? Unhandled error during the execution. Oh, I guess you can handle errors in JavaScript somewhere. Okay, but OpenGL render 405. So it did update frame, got past that. Then it's trying to write that frame somewhere, which I don't want to do. So I'll do this. And a lot of this isn't going to work, actually. Hold on. That isn't going to work. Swap buffers also won't work. While self.animation elapsed time is less than whatever. I don't think I want to do this either. Yeah, I actually don't. Continually update the frame like this. What's eventually going to happen? Eventually this won't call, like, play. Or it won't call construct, actually. And it might not end up calling play. It's going to have to call something like the P5 functions. Set up and draw, and just call those in a loop. But I don't think I want it to handle timing on its own in WebGL. So I think I just don't want to do any of this timing. Can't swap buffers if I wanted to. And so maybe this will do what I want. Okay. Try that. Okay, it actually called this 120 times? I'd expect that to be 60 times. Render WebGL object. So it'd get called here and update frame. Where else would that be called? Or is update frame just be called 120 times? I wonder if it's called 120 times if I run it locally. I guess that's not the worst thing in the world. Where did it crash? Time progression.close, that makes sense. Scene.py 990. So here. Okay, so with that it should survive at least the call to play internal. I want to see if this is called 120 times if I run it not on the web. Let's see if I can just do this. Dot count equals 0. Okay. And look for a scene that just does one thing. Like this. It's called, I guess, 58 times. So why would it be called more? Well, I guess the accurate place to put it would be in render mobject. So here I want to put count equals 0. Do this. Okay, so it is going around 120 times. Okay, that seems like it shouldn't happen to me. But I guess if it's consistent with the local version, that's good. Okay, so just closing that should work. Let's run this again. The scene file ready.finish obviously wouldn't work. Just want to cut that out. Where was this called? Scene 217? Okay, I guess it's good I got this close. There's a bunch of... Okay, I'll put it here. Okay. I went through an entire animation and nothing totally crashed, so that's good. So now the question is, what would I even want this to do? So the question is basically... Yeah, so that's great. So if I go to render web geom object. Yeah, so this is where it has to render the object. And I guess I'll have it update the screen too. Although the timing won't be right even if I do it here. That's fine. Like, it won't be 60 frames per second. It'll just be as fast as it can do it, basically. So I've got regular render object. If I can find that. For starters, I think I'll want this. Let me just go ahead and do the stroke shader, since I think that'll be easier. Then when it comes to this, render vectorized, where is it? This, the stroke. Because this doesn't require any triangulation. It just computes that matrix, then goes here. And this doesn't triangulate, it just basically puts the points in the right order. It does create a shader here. I think what I want to do is all of this. All of this is modern GL specific. So the shader object, setting the uniforms this way, all of this. Then here, this is where I'll have to use that data. But what I'm gonna do, I'm gonna print the stroke data. Actually, let me import JS too. You have to do like js.render. Well, I want to pass. I'm basically going to pass the attributes and the uniforms. So I do like js.render. And stroke data, this is the attributes. I'll deal with the uniforms later. So I compile that. This is going to be called here. Now here's lineage and ear cut. What should I call this? Render object? Let's see if I can make this a function like this. Just try to console log it. Okay. And it didn't print anything. It'd say rendered example, I guess. But okay, that didn't do what I expected. Render object strokes. So render OpenGL object, OpenGL vectorized object stroke. Oh, I don't have this. Use projection stroke shaders. This shouldn't even be here though. It should just be this. Because if it's WebGL, then obviously I want to use the shaders. So let's see if that was all I needed. Okay, so it printed this a bunch of times, which is a proxy. I think that makes sense since this is a NumPy array. But I think it should be possible to translate this to a... Well, maybe not actually. Let me look in the Pyodide docs. There are ways to convert Python objects into JavaScript ones. But I think you have to do the translation explicitly, and it doesn't work for everything. Pyodide.globals.get of whatever .2js. Guess it's 2js that converts it into JavaScript land. Which is new to me. The last time I used Pyodide, that function didn't exist. Look at this, the JavaScript API. No, this is just for loading. Oh, well. Access a Python object in the global namespace from JavaScript. Okay, don't think I'm trying to do that. There's 2Py, and then there's 2JS. I know it's actually, maybe it's not possible to deal with NumPy objects in JavaScript. In which case, what would I want this to do? Here, so this received a NumPy array with data for each object. I go to this website again. Here's temp 1. Can I do like temp 1? And I'll just see what the different fields were. The stroke data is basically this current curve tile coordinate that stuff. Do that. How would I even do this in Python? I'd be able to just index it at current curve. Okay, so that is a proxy, I guess. If I do this.2.js. Is that what I want? Current curve 0. 1, 1, 0. 0, 1, 0. Wait. 1, 1, 0. 0, 1, 0. Negative 1, 1, 0. Okay, so this is correct. These are the curves of, I guess, the square? Okay, so that is right. Cool. So what will I want this to do? Move this rendering data down here where the scene is being rendered. So do attributes. I'm actually going to call this the same thing. Render like vectorized object stroke or whatever. Well, not that. This. So here's render vectorized object stroke. It's going to pass in the attributes. And I've rendered the stroke before in shader scene here. Manum stroke. It's basically just this current curve, passing in the current curves, positions, and color in width. Okay. I wonder if there's... I wonder what's the best way to organize this so that I can pass these individually. It's like getting the current curves this way isn't what I want. I want all the current curves indexed at 0. This might take some NumPy magic. Okay, because when I take the 0 index, I get 3 different things. So I do stroke data at current curve. And how I want to index that. Like, all rows, column 0? Something like that? I think that'll do it. Since I want this one at 0, this one at 0, this one at 0, etc. Okay. Oh, then the way I want to print this. I'm going to try to take it straight to JavaScript. Like so, okay. And I hit some random error. Attribute error render object. Oh yeah, I renamed it. Render vectorized object stroke. What's the error? JS not defined. Man, that printed a lot. Is this what I want? So there are 3 vertices, each of which have this as a first point. 110, 110, 110. Is that correct? Oh, this is the first part of the first curve. But wouldn't it be 6? Like here, there are 6 of them. Here, there's 3 of them, though. Here. In a row. I have to look back at what the shader was even doing. Current curve is going to take curves and then repeat that 3 times on the 0 axis. So the current curve is a 3 by 3 array. That makes sense because it's 3 points. And it's repeating each point 3 times. Okay. It even seems like it'd be 6 here because this has... Okay, well, I guess this already works. And actually, even here it's 6. So that makes me think something's up. Why isn't this repeating in groups of 6? Alright, I gotta try to print it without unrolling. At current curve, I'm just gonna print all of this data. And then JavaScript will convert it to JS here. Okay, run that. I guess it's always printing a multiple of 6. So I guess that's good. Let me open these 5. Okay, so this is repeated every 6. So something else must have been wrong. The way I indexed it or something must have been wrong. Oh wait, not necessarily. These aren't all the same thing. Oh, I wanted to do these. 0 to 5. this. But these aren't all the same either. This is for the strokes, right? Oh, I was thinking of the film objects. Wasn't I? No, I think this used 2 triangles too. Or did it not? Oh man, I got to look back at the stroke shaders. So this. Each vertex took in the current curve and a tile coordinate. Then the point would be transformed based on the tile coordinate. So I thought I was passing each curve twice. Alright, I have to do this in regular Python. I guess if it happens locally as well, then there won't be a problem. It's like this circle. Let me do stroke width equals 4. Okay, now here, if I print stroke data indexed at current curve. Okay. So I put this at 0. Then at 1. Oh, this is a circle. Whatever. 2, 3, 4, 5. Okay. I guess I'm passing each point 3 times. I thought I was doing it 6 times, but I guess not. I hope I don't forget how the stroke shaders work. So there are 6 tile coordinates to go through. Then how are there 3 curves to go through? Maybe I should look at each one individually. Just look at stroke data. And the stroke data at 0. Well, this formatting is really bad. But this is going to be past the first vertex. And the second. Then the third. Okay. So I look at this. Current curve tile coordinate in color. The current curve is the same for the first 3. The tile coordinate is the only thing that changed. Okay, look at 3, 4, 5. The tile coordinate is reset 0, 0, 0, 1, 1, 1. Do Do I expand this somewhere else or something? Maybe that tile stroke data 2. I guess not. This makes me fairly confused on what the stroke shaders were doing. This entire time has been drawing each curve with only one triangle? Okay, now I have to do a simpler example with this. Because if I don't understand how these work, it's gonna lead to other problems later on. So let me render something super simple. Do I have an example with a... I think in JavaScript I had an example with a very simple Vim object or something. Nah, I don't think I have it here. I'm gonna say m equals Vim object. Hey, Daryl Golden. How's it going? I think I do m. I have to do this actually. M dot points equals right? Data at points. Okay. And quadratic does a curve too, and I can do up and then left. Actually, let me do it the other way. Left, up and right. So stroke height equals white stroke width equals 4 or something. Okay. Great. So that's an example of the stroke shader being used. If I edit the shader, and what I'll do is I'll just make the entire triangle be whatever color the curve is. Okay, and it made a rectangle. So that rectangle must have taken 2 triangles to create. So if I go here, if that took 2 triangles, that must have taken 6 vertices. So I go print. Okay, so that's a 6 long. And here, the points are repeated 6 times. The first curve is repeated 6 times. Why is that not happening with the circle? Current curve tile coordinate. And then the tile coordinates are alternating. Okay, so that did exactly what I expected it to. So if I replace this with a square, I print stroke data. How big is this? 24. Okay, so the square has 4 curves. Each of those is 6 each, I'd assume. So the first curve would be this. 1, 2, 3, 4, 5, 6. But here the curve is changing. Although now that I think of this, that I look at this, the tile coordinates aren't even what I'd expect them to be. They're not alternating. What's the next 6? 3, 4, 5, 6. Those aren't alternating either. 2, 3, 4, 5, 6. And these aren't. Wait, how is this possible? It looks like they're out of order, which I guess shouldn't matter. Oh, it must be the way I repeated this. If I look at the first 12, and then the last 12, I bet these here, and this corresponds with this, and the tile coordinates do alternate between those two. And then here, I have these, and that corresponds with this. And the reason that it looks like that, I was probably trying to do something clever. This. Because I saw that that data needed to be repeated. Okay, I guess that's fine. Well, now I understand what that was doing. Which is great. Oh, but now it's going to get a little more difficult to index. Get the 0th part of it. Or to split it up by array. Well, not necessarily, actually. Because if I do this again... print the stroke data. That's this. I put stroke data... colon... What would it be? Would it be like this? Every 6th one? No, that's not right. Every 3rd one. And is this all the 0 indices? It is. If I start this at 3, this is all the 1 indices, I think. Although the tile coordinates aren't changing, so maybe it isn't. Oh. This is the 0 indices. Let me clear this. This is the 0 indices. This is the 1 indices. This is the 2 indices. So, and each of these is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 24 in total. Okay, so this makes sense. Okay, so what I'd want to pass to JavaScript for the current curve 0 attribute. I just try to pass this in an object. So I can call this current curve 0, which is the exact name of the attribute. Yeah, then I can do this. Stroke data at current curve. colon, what did I do? 3. And for 1 and for 2, might as well put the 0 there. Okay. So take out the breakpoint. Make sure this still runs. Great. Compile this again. All right. You can come over here. That startup time, though. Okay. Try this. Okay, map of 3 elements. Current curve at 0 is an array of 8. Wait. Is that what I want? It's at least repeating, or at least I see why it's repeating the way it is now. Let me look at these. This value and this value. So this is gonna be current curve at 0 is array. Wait. Oh, these are all the 0 indices. That's interesting. So then there are 8 vertices with a 0 index. These ones would be repeating, so that makes sense. With a 0 tile coordinate, I guess. And then I'll have to split these up again, I guess? Since you can't pass arrays in the WebGL version of GLSL. Now I'm not sure if that was a useful thing, a useful way to split it up. Maybe what I actually wanted was to index this a second time. I'm gonna go back to Python and try to print this again. We'll leave that there. Just put the breakpoint. This is struct data. And I basically want this column, because I don't know how to select a column in this, but anyway. This first column. That's what I actually want. So I can do a current curve. And that gets me all of these. Then I have to index the first of those. So it'll be... Oh man, what's even the axis? It's a 3-dimensional array? So the row would be 0, Or along the 0 axis it'd be 0. Along the 1 axis it'd be all of them. And along the 2 axis it'd be all of them? Nah, I guess that's not right. Hmm. 0. Yeah, what am I doing wrong here? Man, I wish I knew how to index numpy arrays. Basically what I want is it's a 3D array, so it's like basically this. Okay, so something like that. Okay, and what I want is the first one here. I don't know how to draw it, but like this. Part of it. And how to index that? I thought that the 0 axis would be like this, the 1 axis would be like this, and the 2 axis would be in. Let me see what this does. So I do colon, colon, colon. That's the entire thing. Which should be obvious. If I want the 0 axis to only be... What is with this? That doesn't make much sense to me. If I put this like 0 to 1, 0 to 2? No, it's just indexing the entire thing. These axes might be out of order from what I think they are. Maybe the order of the axes isn't like this. This might be backwards. It might be 0, 1, 2. I think that would actually make more sense now that I think of it. In which case it would be all of them in the 0 axis, all of them in the 1 axis, and in the 2 axis I only want 0. Okay. So now, I print the stroke data, and it was less cramped. I can look at the first column here and compare this. Okay, and this I think looks right. Nope, just kidding. No, it doesn't. The very first one is already not right. Wait, where did this number even come from? 1, 0, negative 1. Interesting. Is this the same scene that I'm running? OpenGL conversion test. That one's also OpenGL conversion test. I try to do that same thing. Just like that. And here, just print it at current curve. Where'd I get 1, 0, -1? Oh, it's indexing like that. What a pain. It's indexing columns instead of rows. Then 1, 0, -1, 1, 0, -1, -1, -1, -1. Okay. So why would that happen? It's definitely all of them in the 0 axis. This, the 2 axis, only at 0. 1 and then 2. This actually doesn't make that much sense to me. It seems like this is flipped. Let's see what this does. It looks like that does exactly what I want it to do. But I don't see why. Actually, the fourth one is wrong. -1, 1, 0. 1, 2, 3, 4. Oh no, that one's right. But now I have no idea why this is right. So the 1 axis has to be down. I have no idea what the ordering of these axes is in that case. But the 1 axis had to be here. Has to be. So what is the 0 axis? It has to be this. Oh, this actually makes sense. You select which 2D array you want. This is basically a stack of 2D arrays. And so you select which 2D array first. Then once you have a 2D array like that, you select like in that order. So that actually makes sense. So now from this standpoint, it's colon 0 colon. Okay, great. Okay, that was fun. So now for current, oh wait, I have to make sure, I have to be able to do this for all of them. So do colon 1 colon. Okay, this looks right too. 0, -1, 0. Yeah, okay, so that looks right too. Okay. So current curve 0. Colon 0 colon 1 and 2. Because that's what I'll pass to JavaScript. Okay, render that. And it tried to hit the breakpoint. Try that again. Okay. Okay, so here, current curve 0. Okay, so 110, 110, 110. Then I go to 12, 110, 110, 110. Okay. That is perfect. I'm just going to keep printing that. Then I'm going to try to pass over the rest of the attributes. The rest of the attributes that JavaScript will need to render this. Also, I should be switching this to that. And I'll take out the GUI. So it doesn't keep making more of them. Great. So I have the current curve 0, current curve 1, current curve 2 data. Position, which is basically the tile coordinates. I have to pass it as position. Okay. So it's position, then in color, then in width. Okay, position, that should be fine. In color, looks right. In width, should be just like that. So most of that work was just because the WebGL version of GLSL can't use arrays. And so I just split that up. Hopefully, passing the rest of these is pretty straightforward. Okay. I guess I can just take the last one. So position is a tile coordinates. So this should be the same down to 12 or 11. Then alternate, which is what it's doing. So that looks right. In color should all be the same. White, width should all be the same. 4. Great. Okay, so that's all the data that I need to render a mesh. Maybe I can just create a mesh on each frame, though that seems kind of wasteful. Actually, updating the data within a single mesh shouldn't be very expensive. I'm just going to create a mesh on each frame right now. I probably need a function like create stroke mesh, something like that. And I'll also have to get these uniforms. I will have to get those. Might as well pass the uniforms now, I guess. So the model view matrix, projection matrix, and the manum unit normal. That must be what I passed here. Model view matrix, projection matrix, manum unit normal. Okay. Yeah, I'll just do that. Or maybe I should have attributes here. And then uniforms. Eventually, like they'll all have this. Well, I guess they won't all have the same uniforms. But a few of them will always be the same. Okay, so here, then I'll put this. Or I wonder if I can just pull this straight from the shader. Probably not. But I'll try it. I'll try breaking right here, and I'll try just... Well, actually, doing it there won't work. Okay, I'll just copy this code. Yeah. Oh no, that's too messy. Let me call this like formatted whatever. I'll take this. And I'm gonna have this. The projection matrix then. Not really formatted. I'll call this formatted unit normal. Okay, so that's a little bit cleaner. Now, here, I can just pass those. I think. Model view matrix, the other one, projection matrix. Then manum unit normal. Oh, formatted. Okay. And there's some error here. Formatted manum unit normal is not defined. What did I do? Oh, formatted unit normal. It's too bad none of the LSP stuff works on code that only works in WebGL, since it considers it unreachable code. Okay, run that. Attributes. Looks right. Uniforms. Also looks right. I think. Yeah, fine. When I wonder if when I rendered this, I had the negative entry in the stroke. It's a model view matrix. Now this is a positive 11. Why? Oh, this is inverted. And I guess when I invert this, it becomes negative 11. I hope. Let's set this dot invert. Okay, then I'm gonna console log just to make sure it has that negative entry. And it does, which is good. Okay. So now, what I want to do is use this data to either construct or update a mesh. And right now I'm just going to construct one. So let's get a buffer geometry here. Actually, this should definitely be a function. This should be like create shader, create stroke mesh, something like that. Let's call this object rendering. Yeah. Render vector is object stroke. This have to be like create stroke mesh. I think that's fine. Then I can just take the attributes here. I have to export that. Like so. I'll import this here. From great. So now here, I'm just gonna log those attributes. Try not to go too fast. Oh, it's not even doing that. Hold on. I want to do this. A mesh will be created here. Even though this doesn't return anything. And that's what I wanted to do. Okay, so now from object rendering, it's printing this data, which is taken from Python. Great. So I guess I just have to pass these one by one. So there's the buffer geometry. I'm actually going to split these. Now I have this data. should be able to do current curve, blah, 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 blah. Okay, so that looks right. This, I should be able to do attributes at current curve 0. And that's it, right? Attributes at current curve 0. Yeah, and each of those is an array. So that seems right. Load 32 array. Okay. You have to do geometry to set attribute. Okay, now this is short enough that I can just do it like that. Low 32 buffer attribute. There. Okay. Have to do this for 1 and for 2. Okay, 0, 1, 2. That looks right. Okay, so I did all of that, then position. Set attribute position, and this is taken from tile coordinate. Actually, I might have just called it position here. Yeah, I just called it position. And this is also three-dimensional. Fine. Okay, so there's position in color. Great. And then in width. Which that's not three-dimensional. This might be four-dimensional. Yeah, that color's four-dimensional. Great. The width is one-dimensional. Okay, and I think that's all the attributes I have to set. Great. So then the material. It's gonna look pretty much just like this. Raw shader material. I have to import 3JS here somehow. Which I... Hold on, I had to do this for shader scene. Yeah, I guess it's just like this. Okay. 3 matrix 4 multiply. Okay. Hopefully I can just pass in the formatted entry from Python. Because this matrix is passed in as a... Both of these matrices are just passed in as a long tuple. I can actually test this. I think with dot entry. Oh, well, let me see. I think if I go to matrix 4 and I do dot entries, maybe Or is it dot elements? Call a major list of matrix values. I think that's what I want. Yeah, okay. So I switch this with dot elements, which is a property, and reload this. So I guess that still runs, which means I should be able to pass the data straight from Python. It shouldn't be attributes though, it should just be data. It should be like shader data or something. Then I want this indexed at attributes. I get the code for translation matrix. Why does it produce a 4-dimensional array? So all of the matrices that you use to operate on model matrices are using homogeneous coordinates. So they're all 4-dimensional. Because model matrices are 4-dimensional. I think if you might talk about this if you I wonder if there's a source on this that isn't hyper confusing. Maybe I can actually just go to my go-to. This? No, this doesn't go over it well. I don't even remember where I learned that, but it is supposed to be 4-dimensional. And the reason is that you're using homogeneous coordinates, and homogeneous coordinates store the translation as well as the linear transformation that you're using. And if you mess with the 4th dimension, what would that represent? When you say the 4th dimension, do you mean... So this is the matrix. Well, not that. This is the matrix. 0, 0, 0. This, I don't think represents anything. I think it's just there to make it work, to make the math work out. Basically, yeah, like there's this part, which is kind of what you'd expect. It has your rotation, translation, and scale. This is always a 1, and this is always zeros. Actually, maybe I should do it like this. And this is the translation. So a translation matrix should look like, I think, identity here. And then the translation here. If that checks out. Okay, that's data attributes. What is actually the way to index this? I'll put uniforms index stat. I just print this again. What's this doing? Current curve 0 of undefined. That's annoying. Hold on, I'm gonna U model view matrix. It's gonna be U projection matrix. It's gonna be mana muted normal, I think. So now I have to figure out why this is saying it's undefined. Okay, attribute set 2.js. Okay, so that's gonna get passed here. Data. I'm gonna log that data. Okay, and it did log it. So let's index the attributes. That's not how you do that. Looks like it's .get, .set. So you want this .get. That's also a map. It's like this? Okay. Okay. It's gonna be... I have to change a lot of this. Messing with the fourth list breaks it. I'd imagine it does. Nothing in any of the... Nothing in the theory like goes over what happens if you mess with that dimension. It's literally just there so that all the math ends up working. Okay. Man, shader source is not defined. Render vectors magic stroke. Play internal. It got all the way down here. JS.render vectors magic stroke. Shader source is not defined? Oh. Oh, the vertex shader and the fragment shader. So I will have to import that. Okay. Okay, that didn't crash, which is great. Let's go down here. Oh, this didn't even create the mesh. Okay, there's mesh. Just return that. I actually just realized I don't have a handle to the scene. Wait, do I? Okay, so here's the canvas. I don't even think I loaded 3JS. Wait. But I had to load 3JS because of this. Oh, this code... Scene camera renderer. This code creates all the 3JS stuff. Interesting. Okay, so I'm gonna take that out. Scene camera renderer. I think I think that should be this. I don't think I need it. Maybe I need this. I don't know. This start renderer. Window device pixel ratio. Okay. So I think I have to take this out of here. Okay, now I have to get my imports right. Try that again. Scene of undefined. App 62. Wait, what? Set property scene of undefined for this. I don't know how to save this to the instance. Well, that's anticlimactic. I think, non-reactive. View switched from view to view 3 in between the last time I used view and now. And so now I don't know how to do a bunch of stuff. A Python 3 moment. Indeed. I did like all of the crazy WebAssembly and all of that stuff. But I don't know how to use this API now. It's gonna tell me how to do this with the composition API? Opt-in reactivity with the composition API. It's reversed. We have to explicitly define the reactive, otherwise they are non-reactive by default. We can create reactive stuff by using ref and reactive. Ref and reactive. Config. If we needed that config to be reactive, we only have to wrap it with reactive. Okay, so I guess that means let's do this. And now they're part of the instance if I return them. I guess that can't be const. Okay. Scene not defined. Wait, where is this? Manum stroke. App.view 79. Here. Oh, yeah. I guess I have to pass in the scene. And the camera and the renderer. Oh, that's up here. Okay, that works now. So now I want to do scene.add mesh and scene like render or something. Renderer.render. Okay. Oh, there's something I didn't like. Compute bounding sphere. Computed radius is not a number. The position attribute is likely to have not a number of values. Darn. Let's see. And the position does have not a number of values. The width is right. The color is not right. And the current curves aren't right. Flow 32 buffer attribute. It's just an array. So here, it wasn't a flow 32 array that I passed here. Let me see. Here's a buffer attribute. The array. It must be a typed array. I'm going to use that to instantiate the buffer. It looks right. There's gonna be something very small. Just like this small type difference. It says it has to be a typed array. I guess if you do float 32 buffer attribute, it doesn't have to be typed anymore. But this one, if I print this, I think that is typed. Yeah, this is a float 32 array. Well, it's an array of float 32 arrays. And maybe it doesn't like that? Oh, this is supposed to be a flat array. This is going to be supposed to be a single array. So it can't be an array of arrays. So I guess I could just ravel everything from Python. Right? I'll just do that. Okay. Okay, well, that didn't crash, so that's good. But it also... So scene.add that mesh and render.render scene and camera. Okay. So now the question is, why didn't that appear? Here, create the mesh, added it. You just rendered that and did request animation frame. Why would that happen? What if I did like... left 2 questions about the changes? Okay, that's perfect. I promise with a set timeout. I'm gonna try to look at this mesh, I guess. See if everything looks right with that. So let's see, here's the geometry, here's the attributes. None of this looks wrong. Let's see, end color. Yeah, that looks right. End width looks right. Position doesn't quite look right. Zero, 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 one, one, one. Oh no, that does look right actually. It must be something with the way it's being raveled. Or maybe not. I wonder... I'm probably going to do something really, really annoying. Stroke vert and stroke frag. Probably got to do some pretty annoying debugging to make sure it does like... Make sure I can do one curve and then go from there. I know this is doable since this does it. Although maybe the projection, either the projection or the model view matrices is something different. Actually, an easy way to do this is just use the same curve that was used here. So that I can compare it 1 to 1. So, like this. But this code here. Up and then right. Okay. So this data should be exactly the same, hopefully, as the data passed over here. So that should be relatively easy to check. Although I won't be able to see it unless I comment this. So I will want to do that. A module named Manum. Maybe that's something with how I refreshed it. Okay. Okay, so I don't see anything. Let me just look through all of that data. Actually, I should be able to do this really easily by just taking this mesh and comparing it 1 to 1 that way. I'll try just doing this. Move that back. Put that there. Oh my gosh. What did I do? There. Mesh.geometry.attributes dot current curve 0. And yeah, that's the same. Negative 1, 0, 0, negative 1, 0, 0. 6 times. Okay, let's look at current curve 1. And what's it? Dot array. Zero one zero zero one zero zero 1 0. Also 18 times. Okay, so that's right. 1 0 0 6 times. So we got position. Which tile coordinates is the same thing as position? 0 0 0. Oh, this is different. The tile coordinates are 3-dimensional. Oh, because the tile coordinates are mapped onto the position. And that position is required to be 3-dimensional by 3JS. So this. I don't want just stroke data at tile coordinate. I want to, I guess, force that to be three-dimensional by just appending a 0. So I'll do that. So there's stroke data. There it is at tile coordinate. Now, I think I want to H stack. I don't know the speed of any of this operation. Will that work? No, I guess not. Compute out zeros. Close, close. And this takes a tuple. And this is gonna be basically 6 by 1. That'll do it. Let's see. I've searched this before. NP append. I think this is this slow? Create a copy of the joint arrays. H stack. This might end up making it slower because it's gonna copy the arrays. Maybe that's not a huge deal. If it's doing it only, it's not doing it in a loop or anything. But I'm literally typing it out here, so I might as well. I might as well not do that. Stroke data tile coordinates V stack of the tile. Okay, here's what I have to do. This is kind of not a great solution. Actually, I can do like towards 1 and then like have this array. Like that. Where'd the, oh. shift work? Or did I shift it? Okay, the opacity doesn't seem like it's working. Oh wait, is it? One way to find out. Okay, I'm gonna shift it left. Shouldn't this work too? Let me see. Left times 2. And I thought we started moving away from these setters. Okay, I'll just do this. Yeah, it looks like it's not working. I don't know for sure if... Let me see. If I look in geometry... Attributes in color... RGB... A. Yeah, it looks like it might not be paying any attention to that. Like if I just set this to 0... Well, that didn't appear. It's a 0 to 0.1. It looks like if it's 0, then it won't appear. But if it's anything non-zero, then it appears at full opacity. But this looks like a 3JS thing. Let's see. As transparent equals true here. The end color is 4-dimensional. If I go to the stroke shader, here, the stroke fragment shader here, the colors of Vec4. So why would it be doing that? That's transparent true. I know it comes from this. Opacity. I don't think I have to set that. It has an effect on rendering as transparent objects need special treatment and are rendered after non-transparent objects. When this is set to true, the extent to which the material is transparent is controlled by setting its opacity value. Maybe I have to do it this way instead of... Like I have to do opacity. And I guess I would do... attribute... Wait... I don't want to have to do that. I would much rather... Because then you could have like objects that are only which have different opacities in different places, which I guess isn't super useful. Attributes.get at in color at 0 at 3. Just use that opacity. Can't even tell if that worked. So 0.1. No, it's still not doing it. What happens if I put opacity at 0 here? Will that just not appear? No, that still appears. So it looks like the raw shader material isn't doing what I expect it to. I mean, at this point, it's something to do with the Three.js. Doesn't this have variable opacity? This has transparent true. That just has RGB and A. But it doesn't look like it's blending with the background. Yeah, I don't know. I'll have to figure out how to even do this with Three.js because I don't even know that much. Do I have Three.js shaders here? No, I don't. Equals V color. Varying vec core. Why is this a varying? Stroke. In color. Then varying V color. So in color gets set to V color here, and V color gets passed over here. Yeah, and then it just gets passed there. Let me try... I'll just make this like... Make this 1, 0, 0, 0.3. This should look faded all the time. Faded and red. Does that look faded? I don't think it does. If I just put 0 here, and then it doesn't appear. Yeah, it's still binary like that. If I put it 1, still. Yeah, there's something with Three.js. Maybe I have to ask on their forums or something. Well, at least I managed to render a render a mobject in Three.js, so that's nice. The fill shaders will be a little trickier because they require triangulation. And I don't know for sure if the triangulation in JavaScript will perfectly match the triangulation in Python. Maybe it won't be so bad. I could probably just copy the same logic used in Python and just use a library for the, use a regular triangulation library. But that is for another day. And then I have to make this actually clear and stuff, but this is huge progress. Wait, why is this printing? Refresh this. This is definitely a lot of progress. Next, eventually I can have it so that there's one function for setting up and one function that's called over and over again to draw things. Cool. Is it running on Three.js shaders? The shaders are from Python, but they're compiled in Three.js. If that makes sense. So I had to copy them. I had to copy them here. These are the shaders from Manum copied into JavaScript. It'd also be nice to get an editor that isn't a text box. That would be nice. Okay. Okay, guess that was working. I want to see if the YouTube was working. Okay, it was. Oh, and someone, I guess, typed something. Okay, it was. Great. Anyway, I'm gonna find someone to raid. Oh, great. Perfect. How about this person? Why not? I'm sure I won't even be able to watch. Oh, hey, I didn't get any ads. Alright, cool. Say hi over there. And I'll see you guys in the next stream.